Hello class, so we are in section 4.3 now, and this section is where I'll introduce the other function I was talking about. So last section I introduced the exponential function, and in this section I'll introduce the logarithmic function, okay? But I'm actually going to start it with kind of its inspiration. So let's pretend we have an exponential equation here. 8 equals 2 to power x. I could ask you guys the question, what is x? Right? And this one is simple. So maybe if you think about it long enough, right, you're like 2 to what power gets me 8? And then you're like, well, 2 squared is 4, and then 2 cubed, so 2 to power 3 is 4 times 2, which is 8, so x equals 3. Okay? So you could figure out it's 3, but how would I use algebra, or how would I actually get the answer if I didn't know it? Well, that's where we get log from. Okay, so here I would normally log both sides, and then this side kind of cancels, and you get 3 here and x. So x equals 3. So log really was invented as a necessity. So you have log a of x, and it is the inverse, okay? Inverse of y equals a to power x, okay, where a is the base. So that's kind of why it was invented, is because we needed a way to solve exponential equations, okay? So now, logs are a little funny, but you can get comfortable with them, okay? So for instance, we're going to use this inverse property to figure out some log values, okay? So if I have log base 10 of 1,000, okay, I want to know what that is. Well, if I just rearrange some things, right? So a is the base, so let me make 10 the base, then an equal sign, and then you see that x, okay, so y should go up here, and then 1,000 goes here. Okay, so we just need to kind of do the same thing we did up here, where I need to figure out what power gets me 1,000, and then here you get the same answer, x equals 3, right? Because 10 cubed is 1,000. Let's do another example. Log base 2 of 32 equals x. Okay, now I'm going to translate. So the base is 2, and then these just kind of flip on the other sides of the equal sign. Okay, so like this moves up, and these switch places. At least that's how I remember it. But then, right, you're like 2 to what power is 32? And then hopefully you're like, oh, it's 5. Okay, and one last one, log base 16 of 4. What is this? Okay, so this one's a little complicated, because then you get 16 to power x equals 4, which, right, that's 4 is smaller than 16. But if you think about it long enough, hopefully you realize that, oh, it's the square root. And so you get x to power 1/2. Okay. All right. So this is how you would calculate logs by hand, right? You would have to switch to exponential and then kind of solve the exponential. Now, let me talk about some properties, okay, that you need to know. So properties of logs. So the first property is that log base A of 1, so it doesn't matter what your base is, okay, all logs base 2, 4, 10, E, okay, all bases, when you plug 1 into the log, is 0, okay? So 1 is like the 0 of log, always. Okay, 2 happens when you match. Okay, so if you have log of A and A, okay, when you get matching things, the answer is 1. Okay, and then now the other two are the inverse properties. Okay, so inverse. So that means log A of A to X kind of cancels because, right, they're inverses. So remember, inverses, when you compose them, right, so when you do fog, they should all cancel and you should get X. And that is what happens because these are proper inverses of each other. So when you do fog and goff, right, they both cancel and you get X. All right, now, how do we use log with our calculators? All right, so this is an important question that some people just skip. All right, but your calculator, okay, depending on what it is, does have a log button, unless it's a, a 4-function calculator. So the log button on your calculator is going to be log base 10. So if it doesn't say 10, if it just says log like this, it means log base 10, and that is what is called the common log. Okay. So all calculators that have a log button means log base 10. Okay. So we have a problem though, because, right, like what if I asked you to calculate this thing? Log base 2 of 32. Your calculator only has a log base 10 button, not a log base 2 or 5 button. So that means to plug into a calculator, we are going to need to know the change of base formula. Okay, so the change of base formula is you have log of a base and a number, okay, and it's equal to log base 10, so I'm not going to put the 10, right? A over log base B, okay? And just for, extra purposes, technically I can make this base any base I want. Okay, so if I wanted to swap it up, I could. It's just the point is we're going to plug into a calculator, right? So you probably just want to do this one. Okay? All right, so that means, quick example, that just means if I wanted to know log base 3 of 7, what I would punch into the calculator is actually log 7 over log 3. Okay. Alrighty then. So hopefully that is helpful. Okay. Now let's talk about its graph. Okay, and other things, the basic information. So log base A of X, okay, first of all, has domain negative 0 to infinity, and range, what did I write down range? Range negative infinity to infinity. Okay, and well, since you know E's graph, you kind of should already know log's graph because it should be, symmetric about y equals x. Okay, but log will have a vertical asymptote. Okay, at VA. That's what we call it. VA at y equals 0. That's a horizontal. At x equals 0. Thank you. All right. So this is log, and its x-intercept, if you remember, is always 1. So you can draw a 1 there to be more accurate. But this is what log looks like. Okay, you should be able to do all of the necessary things with log. Okay, so I'm only going to do one example because you should know how to do transformations by now. But if I had log 2 plus, well, if I had 2 plus log base 10 of negative x plus 2, oh, let me do plus 3. Okay, well, you should remember how to do all of this. Okay, so this is a y-axis reflection because it's inside. This means the plus 3 means go left 3. The plus 2 on the outside means go up 2. Okay, so those are my directions. So here's log, a vertical asymptote, make sure it's important. Okay, I'm gonna go and reflect it right across the y-axis. So now it actually looks like this. Okay. So this would be log of x. This is log negative x. And then now I'm going to do the 2 shifts at the same time. So I'm going to go left 3. So actually that means my vertical asymptote also goes left 3. Okay, so this is x equals negative 3 now. And then up 2. So I'm just going to draw it higher up. So like this. Okay. Alrighty. So that's how you draw log. Okay, you should be able to do it. And now if you notice, right, again, so I mentioned here the domain. This is the third and final rule that we will learn for domains. Okay, so for domain of functions, we now have 3 rules. Okay. So the first one is you cannot divide by 0. Cannot divide by 0. All right. The second rule is no negative numbers in even roots. Okay. We know that we get complex numbers. Okay, but we're like right when we're graphing and doing all of these things, they're still not in the domain. Okay, the real domain. And the third one is the one I just introduced. So no, and I'm gonna say it weird. I'm gonna say no non-positive numbers in a log. Okay, in logs, not in a log. Okay. So the reason I said this is because the square root of 0 is 0. That's fine. Okay. But log of 0 does not exist. Okay. It's like negative infinity if you look at the graph, right? I can't actually plug in 0. So that's why the log of, so it's slightly different. With square roots, you can plug in 0. With logs, you cannot plug in 0. So it should be open parenthesis. Okay. But it's extremely similar. Okay, so you should just automatically be able to answer domain questions, kind of like what that was on your test 1 in previous sections. So if I give you this log, okay, what you would do is the inside stuff right here, you would just put it greater than 0. So right, if it was a square root, I would make it greater than or equal to. But since it's a log, I just get rid of the bar. Okay. And then, right, we know how to do this. So x plus 9, x minus 9, right? This is make a sign chart, critical points, plug in, and we see that we need to be here and not here. All right, so that means x in negative infinity to negative 9. But remember, we can't be 0, so I can't actually plug in 9. So all of these will have parentheses. Okay? And that's the answer. All right. So let's do one more of these. Okay. So let me add a little bit. So let's pretend we have a function, okay, with 2 logs. So log base 2 of x plus log base 3 of 2 minus x. All right, well, so we're gonna find both of the domains and then intersect them, basically, right? Or we're gonna find where we can plug in 1x into both of these, okay? So this one is default, right? This is the normal log function. So this should be x greater than 0, right? Or this one, this little bit would have this domain. All right, this one is different, right? You would be 2x greater than 0. So then that means 2 greater than x, which is actually negative infinity to 2, right? And then now I need to find the intersection of both of these to get the final answer, which is 0 to 2. Okay? The f's domain is just 0 to 2. That's all I'm allowed. Okay? Because if I try and plug in something smaller than 0, this log explodes. If I try and plug in something bigger than 2, this log would explode. Okay? All right. Now, if you remember, I called in the last section, I called e to power x like the exponential function. So it has an inverse, right? Because it's just an exponential function. So this has an inverse function, and f inverse would be what we call like log base e of x, but this has a special form, okay? We like to use ln x, okay, and it is called the natural log. Okay, and this is probably the other log button on your calculator. So you should have the common log and the natural log, okay? And really there's nothing special about it. It's just that it's the inverse to e to the x, okay, which e to the x is special, right? So it does all of the same things. Natural log 1, 0, natural log e, because remember, right, it's technically this, so they match. So it's 1. Okay, natural log e to the x is x, e to the natural log x is x. Okay, so there's really nothing special about it except that it's one of the buttons on your calculator. All right, now you know, and it has the same domain 0 to infinity, same range, negative infinity to infinity, and looks just like all the other logs. Okay, alrighty then. Okay, so that's pretty much it for this section. Okay, I just needed to introduce the log. Okay, it is the inverse of the exponential function. And we will learn more properties about logs next section. All right, that's it. See you guys next class.